We know antivirus solutions rely on file signatures to perform pattern match scanning based on a database of known malware signatures to detect suspect malware executables. Most antivirus software uses hashing functions to identify files, for example MD5 and SHA-1. In this demonstration we will show how easy it is for malware writers to avoid antivirus detection by simply changing the malware file signature, and they are able to change the malware file signature without affecting the malware functionality. This is commonly seen today. Malware will continue to regularly change its file signature after an infection to stay undetected for as long as possible. There are a number of tools readily available to help carry out these functions, and we call them packers, cryptors, and obfuscators. In this demonstration, we will use an open source tool called UPX, which is one of the tools commonly used by malware writers. They would normally modify the parameters and algorithm of this tool to prevent security researchers from reversing the modification. Most malware has no user interface, so we will use the Windows calculator to represent the malware file. We'll also use the freeware tool Hash My Files to inspect the hash references of the versions of the calculator that we'll work with. First, we will take the hash reference of the demonstration file by opening calc.exe inside the Hash My Files tool. You can see the MD5 and SHA-1 values of calc.exe in its unmodified state. Next, we will use the open source command line packer tool UPX to modify the file and effectively create a new file signature. This is a command line tool, and the syntax to use UPX for our purposes is UPX, then our first parameter, 1, referring to the level of compression that will be applied to the input file, calc.exe, and then our second parameter, O, referring to the output file that we are going to create, which is C1.exe. When this command is run, UPX will compress the file calc.exe and create a compressed version, C1.exe, which can be launched in the same way as the file it was derived from, with no loss of functionality. HDF is currently turned on and will block these operations, so before running this command, for the purposes of this demonstration, we will turn HDF off. Now, as we run the packer tool, as described, it creates a new version of calculator called C1, seen here in Windows Explorer. To demonstrate just how easy it is to create many versions of the same file, we'll create a few more, this time applying compression level 2 and calling the output file C2, and then again applying compression level 3 to create C3. You can see all three variants of calculator that we have created, C1, C2 and C3, appear in Windows Explorer. If we open up all three files in the Hash My Files tool and inspect their MD5 and SHA-1 hash values, we can see that they are all different. Because MD5 and SHA-1 hashing functions are what is used by antivirus software to uniquely identify files, as far as antivirus software is concerned, these are different files. They are not the same. Now we can run our original or reference file calculator. The familiar user interface appears. Then we run C1, which as we know is calculator but with a different file signature, C2 as well, and C3. You can see that all of these variant files run just as the original does, but they would be identified by antivirus software as different files. And again, here we can see they're all different. Now, let's take a look at the HDF log file to see what happened as far as it was concerned. A 0 code in this column means that HDF has allowed something to be written to the drive that it is monitoring. We can see from these entries that calculator variants C1, C2 and C3 have been allowed to be written to the drive in the folder Demo. HDF, when turned on, can prevent these types of operation, so malware that was introduced to an HDF protected machine would not be able to change its form and write undetectable variants of itself. To show this in action, HDF will now be turned on, and we will attempt to write a new variant of calculator to the demo folder, this time using compression level 4. And, to make things clear, we'll call the output file that we're trying to write C4test.exe. So we see that HDF is on, and we expect it to block this transformation. The command is run, and we can see that the packer tool throws the input-output exception c4test.exe no such file or directory, and returns the message pack0 files, indicating that it has failed to write the variant c4test.exe, and c4test.exe does not appear in Windows Explorer, and this is because it's not there. Let's take a look at the HDF log files to see what happened. Straight away we can see that we have code 1 in this column, and this means that HDF blocked the creation of c4test.exe, so if this had been malware, it would have had no opportunity to change its form and create new variants of itself. Every time malware successfully creates a new variant of itself, this is called zero-day by the antivirus companies. HDF helps protect against these zero-day attacks by preventing malware variants from being created and written in the first place. For more information on Abatis HDF, please visit www.abatis-hdf.com.